どうも、勝手に電力2.0を始めたいと思います。今日1070回目ということで、このインドネシアのスマートグリッドというこの LPTL からですね、実際に抜き取ってみたいなと思っていますと。Rencana Implementasi smart grid. Smart grid can be interpreted as an electric power network system that is equipped with advanced information technology and communication technology that can enable efficient power management, provide high reliability of electricity supply, utilize renewable energy source, and enable customer participation in electricity supply. In its planning and implementation, smart grid is very responsive to the needs of developing electricity in an area or electric power system. Smart grid technology is developed and implemented in the electricity generation, transmission, and distribution sector, and specifically can support the development and operation of distributed generation system, which will provide the benefits of reliability and adequacy of electric power supply. In practice, smart grid planning and implementation can be adapted to the conditions and the needs of electric development in a particular area. The implementation of smart grid technology aims to answer the challenge of the electricity system in Indonesia, or in this case, PLN, namely, first, operational efficiency. Technical losses at PLN make it possible to optimize and monitor network conditions, especially at the tier level. Two, second, improvement of service reliability optimization of reserve margin in several systems in Indonesia. Improvement of the reliability performance of PLN, SAIFI, and the potential for demand response implementation. Third, implementation of clean energy application of technology to support government targets, especially in reducing CO2 emissions. Fourth, sustainability, the use of limited fossil energy and the integration of new and renewable energy into the system to support the sustainability of the supply of electrical energy. かなり一緒ですよね。もう再エネをどうやって入れていくのかとか、効率化をどうやって進めていくのかみたいなところですね。The adoption of the vision in the smart grid implementation roadmap that has been prepared by PLN provides an opportunity to develop the potential to revolutionize the supply of electricity and increase the likelihood of achieving the government's target in power sector more quickly and more effectively. The need to reduce network losses, increase the reliability of electricity supply, opportunity to utilize renewable energy, and open access to consumer participation in the supply of electricity are new design opportunities in the development of electricity going forward. Implementation of the smart grid roadmap can assist in implementing electricity infrastructure development with the following priorities. Efficient power planning to meet the demand for adequate electricity supply, increase the reliability of the power supply, expand access to the electricity network to increase electrification ratio and support economic growth, develop an advanced metering infrastructure AMI system, application of advanced control center technology and adaptive defense scheme. Implementation of smart grid also develops the integration of renewable energy generators into the power system and opens access for customers to can participate in the supply of electric power. Apart from that, PLN's smart grid also supports the implementation of smart houses, smart cities, and smart nations. Smart grid was developed starting from generation and transmission of electric power, including load dispatch centers, power distribution, electric power substations, and up to customer connection points. Smart grid functions to balance the large generation capacity and load requirements by using the latest information and communication technology so that the energy needs at load point can be met efficiently. In its operation, smart grid can provide predictive information and real-time availability conditions of generator, which will be used by the load control center to manage generation readiness. On the other hand, information on predict and actual electric load of the electrical power system is conveyed to the load controller for the purpose of regulating the stability of the electric power system. With this mechanism, the electric power system can be operated efficiently and with high supply reliability. The smart grid program will detailed in the PLN smart grid roadmap. The smart grid roadmap for 2021 to 2025 is focused on reliability, efficiency, customer experience, and grid productivity, while for 2026 and beyond, it focuses on resilience, customer engagement, sustainability, and self-healing as shown in the table below. That is a table 2021 to 2026, 2026 down through ですね。その後ですね、どういうふうにやっていくのかみたいなところがどんどん書かれていますということですね。The PLN Smart Grid roadmap has started with the implementation of several smart grid development and implementation pilot projects, include development and implementation of smart grid in industrial and business areas, smart community project in the industrial area of Surya, Sipta, Sarna, Karawan. The development of smart grid in industrial areas and business areas is aimed at increasing efficiency. まず省エネ、効率的な利用ですね。By implementing advanced metering infrastructure technology, increasing the reliability of electricity supply with distribution automation system and energy conservation. By implementing demand side management, まず DR ですね。And customer demand response and customer service premier by providing a high-quality power system for premium customers. The smart grid pilot project for industrial and business areas is implemented in the Surya Chipta and Sarada industrial area, Karawan West, Java, which is collaboration between the Ministry of Energy and Mineral Resources, NEDO, the New Energy Industrial Technology Development Organization, and PTPLN, and in this area, business in Batam, as well as trials in tourist areas in Bali. Second, implementation of the automatic dispatch system. The intermittent character of the variable renewable energy (VRE) generator can be anticipated and optimally supported by conventional thermal generators if the production of the VRE generator and the buffer generator is integrated. So the impact is a more stable system frequency so that avoids the possibility of blackouts due to the change in frequency. まさに周波数ですね。Installing ADS is a solution to maintain system frequency stability automatically and in real time. まさに自動でリアルタイムでやっていこうと。Pilot projects have been implemented on Sumba Island NTT Sumba Iconic Island Smart Grid Sumba, which is a collaboration between PLL, BPPT, and the local government in West Sumba, and on Nusa Penida Island, Bali. Third, development of smart microgrid in area with high penetration of ABT generators. The development of smart grid on islands or isolated areas is aimed at developing a local and independent electricity supply for residents on the island or area originating from local natural gas energy potential. Here, a prototype of an independent electric power system is developed for the most and backward islands. By utilizing the potential of renewable energy such as microhydro, solar, wind, biomass, and others, smart grid pilot projects in areas with penetration of EBT generators are carried out on Slayer Island, Medan Island, and Small Island. NTT with integrates PLTS, これはタイプですね, with existing diesel generators. Fourth, development and implementation of smart grid with advanced metering infrastructure technology with proof of concept in several cities such as Jakarta, Bogor, and Bali. ボゴール市とバリ市でやりますとですね。Development of smart grid to increase efficiency, one of which is carried out in the measurement technology development program metering using the advanced metering infrastructure. By using two-way communication technology, it is expected that the measurement of energy distribution at each distribution point will be monitored and managed so that the distribution of electric power can be carried out efficiently. The developed AMI technology includes technical schemes for data retrieval from customer meters to data processing centers, meter specifications that suit AMI needs, two-way communication media, meter data management system, and data analytics capabilities. Here, it is also possible to develop a metering operation system control center, smart metering operation center, which function to increase operational effectiveness, reduce risk, and carry out the best practice processes for electricity transition measurement systems, standard operating procedure, security monitoring, control, and reporting. Fifth, development of advanced control center. The complexity of an electric power system drives high demands for upgrading automation technology. System control that in real time and continuously must meet security, reliability, quality, and economy. So to meet the above criteria, an automatic dispatch system is needed through the development of an advanced control center. The development of this advanced control center must be able to anticipate the challenges of controlling the system with the growth of disruptive technology. Unpredictable demand characteristics, intermediate characteristics of variable renewable energy generators, and the application of energy storage systems. So that the real-time technology that needs to be developed includes the integration of weather forecast, まさに天候予測ですね。気象予測、load forecast, economic dispatch, automatic generation system, reserve margin monitoring, production marginal cost system, contingency analysis, voltage stability analysis, dynamic simulation analysis, wide area monitoring system, and wide area protection scheme, enterprise information system, and cybersecurity system. The application of advanced control center technology can be implemented in groups of distributed control centers, centralized control or semi-centralized control centers. A. Integration of weather forecasting, load forecasting, economic dispatch, automatic generation system, development of the weather monitoring system and forecasting. PLN has collaborated with BMKG. WMS is an additional input for real-time load forecasting. This WMS can also be utilized and integrated later if a VRE type generator operates. Result of generator economic dispatch optimization that are integrated with load forecast within real-time sense economic dispatch scheduling to generators via AGC automatically, so that this integration application is expected to minimize control of the energy management system through manual orders by dispatchers, with the aim of reducing deviation and increasing the efficiency of generation production cost. B. Reserve margin monitoring, the activation contribution of the free governor and AGC generating unit and system can be monitored in real time so that the condition of the system's rotating reserves, both fast response and slow response orders, can be controlled in real time by the dispatcher. With this application, it is also possible to calculate more effective penalties against generating unit due to the inactivity of the free governor and ancillary service or for AGC activity. C. Production marginal cost system. Through this monitoring system, dispatchers can monitor production cost in real time and marginal and subsystem cost. D. Contingency analysis, voltage stability analysis, dynamic simulation analysis, wide area monitoring system is a real-time power system analysis that can assist the dispatchers in projecting risks quickly, early warning system for work outage plans or when disruption occurs in transmission systems generators so that dispatchers can make decisions in controlling the system quickly and precisely. E. Enterprise information system and cybersecurity. 6. Development of adaptive defense scheme, WAPC, RAS, SPS are technologies for system protection. The adaptive defense scheme technology for system protection can be developed with contingency based such as RAS and SPS as well as PMU. based such as WAPS according to system requirements. However, the adaptive defense scheme must be able to be monitored through the control center so that dispatchers and system engineers can analyze it effectively through fast and comprehensive data acquisition. The system protection technology is implemented to be able to maintain system stability when credible disturbance occur. 7. Application of digital substation. Digital substation is the terminology used in electrical substation installation systems where monitoring and control systems are managed by distributed intelligent electric devices that are interconnected by a communication network with digital substation enable the use of computing technology in substation system parents. The pilot project of digital substation is proposed by the 150 kilovolt Sepatan 2 substation plan and the 150 kilovolts Terrakunaga 2 substation plan. 8. Prediction analysis on power plants. The application of this technology is for prediction of the condition of power plant assets, which aims to analyze asset performance, operations optimization, and boiler optimization. Implementation was carried out at PTPJB with remote engineering, monitoring diagnostic optimization center program, and PT Indonesia Power with the reliability efficiency optimization center program. 9. E-mobility platform for the existing EV charging stations or PLN implementation of making platform for public electric vehicle charging station or EV charging station in the cities of Jakarta, Bandung, and Denpasar. 10. A blockchain project, a feasibility study for implementing blockchain technology in the existing business processes at PNN needs to be carried out to identify in more detail the cost and benefits that can be obtained by implementing blockchain technology. One application of blockchain that has potential benefits in the form of the new source of income for PNN and anticipates the development of distributed energy resources on the PNN grid is peer-to-peer energy trading and renewable energy certificate trading. So that currently a further study is being carried out regarding the business model of peer-to-peer energy trading and renewable energy certificating trading that can be implemented at PNN. That's all. Thank you.